There we go. Okay, welcome to today. I had previously tried to record this, but of course the mic wasn't on. There's a service in the mic hook from the sort of dual band headset gets really weird sometimes. So as I say, it's time to re-record it. So if you were wondering what accessible Kubernetes was supposed to be, now you get to find out. Congratulations, you're here for the real thing. There's some backstory to this, but at the end of the day, I'm going to walk through a nice pattern of, I don't know if you call it a stack, it really is more of a pattern. It has three specific objectives in mind. But behind all of this is the fact that Kubernetes is not particularly accessible for like small, quick projects. And that's a shame because there's really no like realistic alternative for orchestrating self-contained stacks of technology. Not in the modern universe, at least. But really what we're going to try to do here is we're going to try and show how it can be actually fairly easy to spin up a cloud-based Kubernetes cluster that it's fairly easy to deploy with the right combination tools. We also want to show how that can be used to have sort of a self-contained app and infrastructure where you're writing the full stack of the app and the infrastructure to deploy it all within the same project. That can be a really nice copy-paste to use for small to medium-sized applications and a lot of different challenges. And then we also want to show that this isn't just half-assed. Specifically, that pattern that we set up is actually not impossible to go through and register in an automated fashion for domain names and subdomains and TLS certs and everything else that goes into it. So this is something that can actually be used. And this is something that I've actually used on personal projects and other things. So without any further ado, let me close this, which is completely irrelevant. That's what I'm trying to talk about. Close folder. There we go. And let's get started. So what should we call this? Let's call it accessible Kubernetes. Why not? Voila. Blank page, right? Specifically, there's a combination of three things that we're going to be putting together here to make that possible, to realize the objectives I mentioned. The first is we're going to be deploying this as static infrastructure as code, and that means we're going to be using Terraform. So we will have a procedural definition and bindings between all the resources in a repository of code. That will include the static files, but it will also include the infrastructure and all of the associated resources and namespaces that go with that to fully deploy the cluster, right? The second, of course, is that we are using Kubernetes. That's the third, or the second technology here. The third is the provider itself, and you have a lot of different options for this. I find myself in recent years strongly biased towards DigitalOcean. It's like the perfect sweet spot of they're big enough to give you a lot of capabilities and a really nice provider, a Terraform provider. But small enough that they're actually changing things, and it's not impossible to wrap your head around everything they provide. It's also very nicely priced, if I don't mind saying so myself. So let's start from scratch here, in which case we're not even going to start coding yet. We're going to start by talking about the domain, because every project needs its own domain, right? This is actually one of the places where DigitalOcean falls short a little bit, insofar as it's not actually a registrar. They operate their own name services, and you can do automated record management. You can respond to DNS01 challenges for your cert requests and all that. But you would need to register a domain somewhere else and then point it to the DigitalOcean service. So that's really the first step here, is go to GoDaddy or DreamHost or Cloudflare. I found myself using Cloudflare a lot more lately. They also have a nice Terraform provider, by the way. Register your domain and then point it to the DigitalOcean name servers. So it's ns1.digitalocean.com, ns2, ns3, etc. And once dnschecker.com tells you that all of that, it is .com, right? .org, I was mistaken. Once dnschecker.org tells you that all those records are propagated and that DigitalOcean is now being used to respond with the records from its name servers, then now we're ready to set up the project, right? So let's say you have mydomain.com. That's your experiment. And let's get started with the project. So if you don't have a DigitalOcean account already, this is a great time to sign up. I think they come with like maybe $200 or so free credits when you first sign up. So you're not actually spending any money on this. That having been said, like the Kubernetes cluster rates are fantastic. You have full control over that. Maybe not as much, budgeting restrictions you might on Azure or something like that, but you don't need to worry about blowing budget. And certainly the $200 of free credit is plenty enough. So if you look at, pull it up here, once you have an account from the dashboard, the main thing that you need to do first is pull up an API token. So you would generate from, see, is it settings or API? Here we go. Pull this over. So you would go and generate a new token here, give it a name, it'll give you a value, make sure it can write resources as well. And then take that token and put it into your environment. In particular, this is a fun Terraform trick, tf_var_, in this case, let's say do token. Let's say on Windows, you'd say something like that, right? Will automatically be parsed by the Terraform runner into the variable do_token if it's defined. So that way it's never touching disk, right? And that's the better way to go about it. That having been said, we are going to ignore that rule here and start with the TFRs. So this is basically the same thing, and I can actually show you that, of course. But we'll define our variables here. We'll make sure it's not committed to version control. And now we can start saying, what are the variables? The documentation for Terraform providers in general is very good, but in particular for DigitalOcean is just outstanding. Let me show you. Very easy to get started. Copy paste, right? Boom, off to go. In this case, the API token is passed, I believe, by the token field. So let's create a providers. Define what the variable was. There's a few other providers we're going to use here. So we have our DigitalOcean one. We're also going to use the Kubernetes provider. Surprise! And then we're also going to use, this is actually kind of nice, there is a built-in Helm provider. And then we have token, here we go, Kubernetes, and there's more that will come for these because they will use the outputs of the DigitalOcean cluster deployment in order to configure the actual parameters for that connection. But that is enough for now, and it's certainly enough for us to, let's see, let's pull up our other variables and define a few other things too. This is a string, API token for DigitalOcean account. Wouldn't be a stream if I wasn't fingering everything. We're going to want to pass in sort of the Apex DNS record, so mydomain.com, for example. That's going to be used to construct the FQDNs, fully qualified domain names, for all of our ingresses, and it's going to be used when in the cert registration process. Speaking of cert registration process, it's helpful to pass in an email address to use. And I find it's very useful to say which specific Acme server for Let's Encrypt, in this case, that you're using, because when your cluster issue is initially spun up, you don't want to risk running into the rate limits. for like production Let's Encrypt, right? You want to use the staging server. If you define this as a variable, it's very easy to then, once you're happy with how everything is up and running, go in and change the variable to the production server, reapply, and poof, you know everything is working and being executed with the same configuration. So, did I mess it up? Yes, I did. All right, I will move this off screen so you don't see me put the tokens in. Okay, so this is enough to get us started. Let's go ahead and I think we should be able to Terraform init. Of course, it's not going to like the fact that I haven't added the token yet. So let's do that now. Is it going to come up in the main window? No, it's not. Yay! Okay, I have a particular host I've used for this process. Put that in, and let's see if I can memorize it. Let's encrypt staging. You know what? We're going to search for it. I haven't memorized it. Okay, so here, well, staging URL, we will set that as our Acme serve for the time being, and we're ready to go. Okay, now we should be able to init, and now we can, oh, we didn't start tracking. Don't track our state. So basic project, or should we create our first module? Let's just do a project here. So just for demonstration purposes, sort of like a namespace in Kubernetes, you can define projects, and we'll just copy pasta here. Yep, that should be fine. Yes, for sure. Boom, just like that, we're up and running DigitalOcean. Okay, so that's useful, but we haven't actually done anything yet. So I find there's a very useful isomorphism here where you can organize your Terraform projects into modules, of course, and then each module effectively I like to use to define a specific Kubernetes namespace. So it's like module is a namespace, right? We haven't actually deployed any Kubernetes stuff yet, so at first we need the DigitalOcean resources, and in that case I'm also going to create a Terraform module. This one we'll say is just for DigitalOcean resources. We'll move our project in there. We'll add a top-level main. With this approach, I find more often than not, the main is primarily just used to define and integrate the modules. So we created a component source here. Okay, so now we have a project. We're happy. Because it's a non-default provider, you also need to tell Terraform which provider should be used here, and that's basically just a copy paste. Otherwise, it's going to try to get HashiCorp DigitalOcean, which doesn't exist. Okay, so now is the fun part, because in addition to renaming things here, we can actually spin up the cluster. Speaking of heuristics, I find it's helpful to give the file name the same as the resource name of Terraform and the same as the resource name for whatever the provider scheme is. It just helps simplify it. You know at a glance exactly where everything is, what it is. You don't have to open it up and unpack. And then For projects, there's an empty block here that you can start populating with the URNs once you actually have resources. So this should be enough to, it's actually that from Terraform's perspective, nothing will have changed yet. So let's go ahead and define the cluster now. Kubernetes cluster. We'll put it in San Francisco 3, 29.1 DO0. Correct? No, it didn't. And then the sort of pool of nodes that will be used, we'll call it worker pool. Specify a size to virtual CPUs and 2 gigabytes of RAM. That's pretty small, but I'm not going to be doing much with it. And we'll say we want 3. Okay. So I find it's very helpful. I'm not going to do it in this case for lack of time, but region, the Kubernetes version, and the size, specifically sort of the droplet or VM size used for the node pool, are helpful to pass in as variables as well. You pull it out to the top level, and now you can say, you could do it with node count too, but that's probably going to be more, there are tricks to automate that more in response to load. Okay, actually I want 4 gigabytes of RAM on this, so change it, reapply, right? Or, oh, well, I need to update the Kubernetes version, it's much more straightforward. There's a nice handy reference page for those things. For DigitalOcean, slugs, do, API dev, you can see, okay, here's all the possible values for the droplet sizes, different regions that it supports, different Kubernetes versions. This changes on a pretty regular basis, by the way, every few months. You want to not get caught too far out. You get some interesting Terraform messages. But this is enough, actually. Or at least it would be enough of it. There we go. I had to find a new module, and I didn't initialize it. Okay, so it's going to go off, and this will take a few minutes to spin up a cluster. It's not spinning up Kubernetes clusters is never particularly fast. But it gives us some time to define a few outputs here. So what do we want from this module for other resources to use? First, we're going to want the kube config. And this, strictly speaking, isn't necessary. But I find it's very, very helpful to be able to debug from the command line after you've done specific deployments from Terraform. To figure out exactly, okay, did this work? Let me inspect it. Let me debug it. Let me look at the logs if something went wrong. You still have the static specification of the Kubernetes resources, but you can still go in and mess around in real time after you've deployed things. Very useful in my experience. But for the actual provider configuration, the Kubernetes and the Helm provider, you're also going to need to know specific properties from that kube config. And instead of trying to parse it, it's easy just to pull it straight out from the resource. So in this case, we want the endpoint for the control plane. The provider will also need the token to identify the cluster. And of course the certificate. See, this is always the fun one. New cluster CA. And that, of course, is sensitive. So as module outputs now, we can actually go back to our providers, uncomment these, and this is now something we can configure. So host is just the output of that project, right? Cluster host. Same with cluster token. And we also need CA. Bomb. And the nice thing about this is, how do you configure Helm? You take this block and you paste it in here. This is just called Kubernetes. And you're done. You're good to go. So we can actually go in here now, or at least if this wasn't still trying to create the Kubernetes cluster. It does work. It does happen. It just takes a few minutes. We might as well add this. Do not want to commit any of these things to version control. So now we can just go in and use the Kubernetes provider and spin up random Kubernetes resources all we want. Namespace by namespace, project by project, module by module. and do it all within Terraform. So speaking of which, there's fundamentally three legs of what I think of like meta services, or meta applications, I guess. Service is such a vague word, to a given cluster. There's like load balancing, right? You need to define how traffic is going to be managed once it hits. You need an ingress controller to enforce the ingress rules against the load balancer. And hopefully you need cert manager, right, to secure TLS termination at the ingress, and do so in an automated way where you can control the certificate resources and the cluster issues, actual resources within Terraform and Kubernetes. So before we think about spinning up any specific, application code, what have you, we want to think about how do we make sure that those meta applications, meta services are there as part of the cluster. And we can do part of that as part of the infrastructure as well. So let's start with, what do we want to do first? Let's start with the ingress controller. We're going to give it its own namespace. So let's start by defining that namespace. And then we need to add that to the top level as another module. And I'm going to go ahead and cheat here and just put in what the variables. So it's going to need the name of our host. Let's see if we can demonstrate applying this yet. Yes, we can. We create a new module, so we need to initialize it. Hostname, not expected. Did we not define it as a variable? We didn't define it as a variable. Okay, host. Right. And we're good. Okay, so now, speaking of which, we will go ahead and Terraform output raw kubeconfig. We haven't defined any outputs. Let's do that now. So in this case, basically we want to relay the kubeconfig output from the DigitalOcean resources module. And now, here's a fun trick. Terraform output -raw kubeconfig. There's our kubeconfig. We'll put that in a YAML file right here. Add it to gitignore. Yeah. Moving too fast. Okay. And now if we set, was it kubeconfig? I'm on Windows, so excuse the unusual environmental variable format. Did I do YAML? I did YAML. Voila. We have kubectl access to the cluster we deployed to DigitalOcean. It only took us 10 minutes, thereabouts. So now we can really start get going with the interesting stuff. So let's go back to the ingress controller for a moment. And let's see, what do we want to do first? So for the ingress controller here, typically we would actually want to do the load balancer first. But load balancer implementations are, they differ, right? They vary from provider to provider, and if you're doing an on-prem Kubernetes cluster, you need your own, and it's either going to be part of the substrate, or you need to roll metal LB, or what have you. In the case of DigitalOcean, they actually give you the load balancer hooks for the native provider load balancers automatically. And that will hook into the Kubernetes substrate as it is, so you don't actually need to worry about rolling your own load balancer. So in this case, we can skip straight to the ingress controller, and this is where you will see we're going to use the Nginx Helm chart, Nginx ingress controller Helm chart. So this is, you'll see, very nice to just be able to say, oh well, there's a Helm chart for that already. So long as there aren't too many customizations required for the configuration. Sometimes you can pass in and control everything you need to from the values of the Helm chart. Sometimes it's just too much and you need to go through and deploy those, do an individual deployment or what have you. But in this case, the Helm chart actually works out pretty well. So this is coming from Nginx repository. If I can remember which ones are called Nginx Ingress and which ones are called Nginx Nginx. Procedurally bind the namespace. Did I get it right? Probably not. There we go. And then there's a few things we are going to want to set here. First, controller ingress class resource. We're going to set this as the default ingress class just so we have to do less work later on. And we also want to make sure we are publishing the controller source. All right. That looks okay. Let's apply it. So there's going to be a lot of stuff that gets rolled out as part of the ingress controller. We'll see that in a moment. But in particular, one thing that we do need to extract, and this will be sort of a data reference, right, is the service, the corresponding service. So we'll need to reference this for the domain records because it will have the actual IP, the external IP that we register for the A records. And there's a special naming. Maybe I should show you. It's still creating. Okay, so it's going to be, as part of the Helm release, name dash chart dash controller. So basically this is going to identify a service from which we can extract the external IP and reference it in subsequent resources, specifically for domain control. Since we're doing this downstream of the DO project, there's still going to be some DigitalOcean resources here for the records. And that means we need to control those with the DigitalOcean provider. I'm just going to go ahead and copy paste here. Do that correctly? Yep. Okay. So we'll want to identify our domain. So this is basically our Apex record. We have that as a variable, although we need to pass that in if I remember correctly. Nope, we already did. Fantastic. And then the IP address is going to come from that data reference. So we have the load balancer. It's going to have a status. That status is going to point to the load balancer being used. It's not 3 S's. It's going to have an IP property. So that's the Apex record, right? We also need, well, actually, technically we don't need this, but especially in a cluster, if you're going to do like prefix-based routing, I find it's very helpful to also add a second wildcard record here, just to say, while you're at it, right? And we can point directly to the DigitalOcean domain ID and say there's other records here. In this case, it's an A record, wildcard, so it'll capture subdomains, and it's going to have the same value. A lot of users reference it like that. Okay. Are we ready? Still working on the ingress controller. This can take some time. In particular, it takes some time because it does have to reach out to the provider native load balancer. And that in turn will have to get an external IP address, and that's not something that happens right away. Several minutes typically. But you can keep working while it's happening. I think we're actually good here. Let me make sure. Do we have any outputs from here? No, we don't. Once that's spun up, we'll have an ingress controller, and then our ingress rules will be able to use it, right? So now let's talk about certs, because this is where things get fun. Or should we look at the, let's look at the app deployment first. So technically this is downstream, but it can help sometimes to just verify over 80 HTTP that plain text traffic is working for the deployments before you actually apply TLS termination, because that's a pretty small step once you know it's done. So let's just go ahead and do a basic static files Nginx container here. So that's going to start with the deployment. When in doubt, think about 3 application resources you need in Kubernetes. You need the deployment for the container, right? That deployment is going to have endpoints defined within the cluster by a service. And then that service is going to be identified by the ingress rule and mapped to a specific like subdomain or the routing rule. And that's probably the most convenient place, at least, to do TLS termination. The ingress rule will be picked up by the ingress controller. So let's go ahead and do the initial deployment here. Haven't actually defined that one yet, have I? That's probably the next thing I should do. Let's do that now. The joys of live coding. All right, now it has that reference. What is it? Spec, template, spec, container. Did I remember the order correctly? Spec, template, spec, container. Yes, I remembered. Okay. So let's define some variables here that we can reference as part of this. In particular, I find it's nice to be able to, not a resource, variable, pass in a specific application name for 2 reasons. The first is you have a common base to use when you're constructing labels. For like services and deployments, and that way you don't have to worry about fat fingering any label associations. Second, of course, is actually using the app name as like the subdomain, right? The prefix for the ingress rule. So this is going to be used to construct selector labels and subdomains. Because we're going to be constructing those things for the ingress rules, we also need to know the apex name to construct the FQDN. And lastly, once cert management is working, we'll need to know the name of the cluster issuer. I should come with that one out for now. Let's come with that one out for now. Okay, now we can go back to deployment. Let's finish defining this. So spec, template, spec, container. Yeah, I got it right. Okay, so one replica. Do that procedurally. Sometimes you'll have multiple applications within the same namespace, like if there's a database or a log/relay or what have you. You can still construct those procedurally, but embedding that as part of a string dash sub app or what have you. It is worth it. It does make your life a lot easier. Someday we'll understand why you need 2 labels defined within the same resource. And then God bless Nginx. We good? We're good. Okay, so that's the deployment. So remember, deployment, service, ingress, right? Deployment, service, ingress, deployment, service, ingress. Let's define the service. Service also needs a spec. Selector, yep. and port. Keep in mind, services are internal endpoints, internal to the cluster, so in this case, 80 to 80 is fine. And now we can identify that procedurally by the ingress. How are we looking over here? Context deadline. So in this case, it took too long to get an external IP address. Sometimes that happens. Let's see if we can just reapply while we're working on everything else. All right. Okay. And lastly, but certainly not leastly, ingress. Someday I'll understand why this isn't just a first-class Kubernetes resource. Eventually we'll also want, might as well add this here and comment it out. Cert Manager is going to be using the annotation to identify what cluster issuer to look up. And we'll comment that out for now. Spec for the ingress is, I think we defined a default ingress class. Had that anyways. Always catches me off guard. And a rule. Eventually we'll have a TLS block here. Okay, so we need a host. As mentioned, we'll take the app name and we will prepend that to the host name, and now we have a subdomain record. For HTTP traffic, root path, identified by prefix for that subdomain, and then point to the service. And this, of course, is where Terraform really comes into shine, because why would you want to guess and check when you can just say, this service is that service over there? One source of truth, right? Fewer places. I've misspelled Kubernetes so many different and interesting ways. It actually, the creativity actually impresses me sometimes. Spec, port. Okay, and that's it. We'll get to this once we have Cert Manager up, but this would be enough to define an ingress rule based off of subdomain for HTTP traffic. How are we looking on the IC side? Still creating. Again, that can take a while. It can be error prone, but I think we are mostly good here. Okay. Yes. So last but not least, Cert Manager. And here's the big one, right? This is typically like the biggest lift and probably one of the trickier things to do if you don't have the right combination of technologies and integrations. So let's start by defining what we're going to need to pass in. We're going to be using an Acme challenge, so it's going to need access to the DigitalOcean provider token. Sensitive, true. We're also going to need all that good Acme goodness. You know what, let's copy paste. We need to know what server cluster issue is going to be using. Here we go. Okay, so, and we're going to need a namespace. Let's get that namespace going. Did not spell that correctly. All right, that should be good. So again, being able to use Helm when you can automate a lot of that is very nice. Let's look at Cert Manager documentation for a moment here, because this is worth sharing. In particular, we are going to be using an Acme challenge, DNS01, because if you look at the Cert Manager documentation, there is built-in support for doing so with DigitalOcean managed records. Ooh, I didn't realize there's also Cloudflare. I guess that shouldn't surprise me. I should try that at some point. And it doesn't take a lot of imagination to figure out, okay, you can transcribe these to the Cert Manager structure for the Terraform resource too. And that's exactly what you do. You pass in that in as a secret, boom, you're good to go. And that will automate a lot of the DNS01 challenge, like record, specification removal, etc. very nice way to go about it. So let's do that. Let's use, boop, wrong one. Let's define the release. It's Helm release, cert manager release. I do find some charts are very sensitive to what you name them, and that's not always obvious from the variables or the values that they declare. Jet stack. In this case, the only value we need to assign is the custom resource definitions, or CRDs, are very important. In fact, it actually can cause a problem for Terraform because it doesn't have any knowledge or awareness of what those resources are or how they're defined until you've actually rolled out the Helm chart release. So even if you use like depends on in Terraform, right, to say the cluster issuer needs to make sure the Helm release is installed first, right? Terraform still doesn't know and can't verify through the API like if the actual cluster resource, even if it's not being applied yet, is well defined, what the schema is, etc. So first you want to apply the Helm release, and then if you install the CRDs as part of that process, then hey, look, see, and we're second time is charm. We define new modules. I have not hooked those in yet, so let's do that now. We had what are I can't remember all the variables that we had though. See, we had host name, we had app name. We're just going to say it's www, and we had cluster issuer name that we haven't defined yet. Okay, and then we had Acme email. All is defined. Yep. Okay. That should be good to go. And now we'll go ahead and spin up. Just kidding. Always forget to init. We done goofed it. An unreadable module directory. That means I messed it up. Certs namespace, source, certs namespace, www namespace, www namespace. Yep, here we go. Use for the other one, certs. Yep, that one's inconsistent too. Copy, paste, paste. Consistency is nice. And then we probably did the same thing for www, didn't we? Namespace, namespace, main, no, that might not have been the one that I was complaining about. There we go. So, search namespace, module, outputs, no. Where did we mess up this time? Search namespace, line 6 of Helm release. Raise namespace, yes, we changed that name. Search. Thank you, Terraform, for catching all of our mistakes. It's like a friendlier version of the Rust compiler. Okay, so that's going to go off and spin up the release. Once it's done that, now we can define those custom resources. So we'll start with the cluster issuer here. Because it is a CRD, we want to use a manifest structure here, so we can just directly define sort of the map. Was it IOV1? Did I get that right? Yep. We're defining a cluster issuer. It's cluster wide, so it doesn't need a namespace, and it has the following spec. And all this comes straight from the cert manager documentation. You can copy and paste it if you want. Acme, here's where we use our Acme parameters. It's going to need a secret for the key that it gets when it succeeds succeeds, the challenge succeeds. This is not something we need to populate. It's just the reference that it uses for the place that secret will be stored. And here's the fun part. So it's worth reading up on Acme and DNS1 challenges if you're not super familiar. Suffice it to say, the fact that we have a provider here that also manages our domain records and has built-in support is a beautiful, lovely thing and saves you a lot of pain. I've done this without it and with others, and believe me, this is nice. So we're going to pass in the API token from a secret that we haven't defined yet under the access token key, and that's it. So let's go ahead and do that. What do we call it? DO talk secret. So that is a Kubernetes secret. And the data is going to come from our DO token. Voila. So now it is accessible by our Kubernetes resources, in particular, in this case, the cluster issuer. Let's see. Are we leaving anything out? We might want to define some outputs here. As referenced earlier, the name is going to be used by the annotations of our ingresses. So that's going to come from our manifest, cluster issuer, metadata, name. Just add a note here. That's probably more detail than needs to be, but that will work. Okay, what are we missing? This is always a good sign that there might be something wrong with what you're trying to parse. Missing this cluster issuer. Oh, that's right, because it's a CRD. Okay. What do we got? We got the release, we got the namespace, we got the cluster issuer, we got the DigitalOcean secret, we got the outputs, and we have all of our variables. So, you know, live coding, will it work the first time? Who knows? Metadata. Usually that's a numbered field. Let's look. Cluster issuer. Manifest metadata. Name. Oh gosh, I'm going to be embarrassing myself here. There is no, manifest. Yeah, that would help. No! Too many hotkeys. My fingers are faster and fatter than my keyboard can tolerate. No, cancel. There we go. That's right, because I was trying to save it. Okay, there we go. So this is where the magic happens. And fortunately, we don't have to worry about the magic. It's all being handled under the hood, although it takes some time. If you look at there are no certificate requests because we haven't enabled TLS yet. So let's go back to our ingress and talk about that TLS block. Make sure it has access to the cluster issuer name. Let's make sure that's being forwarded. There we go. And now we can say in our ingress, you are no longer comment out. You are going to request a specific cert for a specific host, and you are going to store that cert's information in something that I can't spell. There we go. Again, we don't need to define that secret. It's simply a place for storage for the TLS properties in this case. So now that there are TLS properties, it will, you should be able to see a cert request going through. Check our services. While we're at it, okay, you can see our load balancer has an external IP. That's being used to pass off all the records. Let's look at certificate requests. Did it finish already? Or did I break it? No certs. Okay. Something's going on. This is enough. Believe it or not. And I will prove it to you by going here. Voila, Nginx. Yay! And let's test that. That might actually not work. 80. Yeah, so it's having issues with the record management. It makes me wonder what's going on. Oh, it's because I registered this and I tried to transfer it. Dang it. I knew I shouldn't have done that. You can see 80 and 433 traffic are supported by that endpoint. You can look at the ingresses across all our namespaces. There's our ingress. There, it's using the right host. Assigned that address. Has the right traffic. Yay, we're happy. So that's it. This is probably what I missed, isn't it? Let's see if that does it. No sense in porting a cluster issuer name if we don't actually use it. Hey! Pew, 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 pew. You can see it's been approved by the internal cert manager. It's not ready yet. It's still being filed and requested. And then what you'll see is it can't be used because this is from staging. So wait a few moments here and probably still going through the challenge. Don't get too much egg on my face here, Kubernetes. Okay, so it's going to take some time. Sometimes the cert request might take a few minutes, to be perfectly honest, but it's nothing compared to the Helm chart releases that we were waiting for earlier. Other sort of top-level highlights here. Let's see. That's most of the highlights. You can ignore the certs if you want to do like a curl kv command just to test the responses are working from that endpoint, especially for 443. Let's look at the certificates and just check one more time, see if they're ready. Hey, there it is. So let's see now. Not routing yet. So the domain record is trying to catch up, but cert request succeeded. This is a very good template. So what you would want to do at this point, now that you have a functional cluster, is focus on populating the application container here, using sort of some sort of packed project, for example, on the front end to define what the contents of this container are. You may want to flesh this out with a container registry, so that you can push the images and then pull them with the appropriately constrained credentials from within this deployment, bumping tag information, etc. But now you have those static files served as part of that deployment, and that's just an Nginx like copy, right, in a Docker file. And it actually ends up being pretty straightforward to do like full up infrastructure deployments from a Webpack app. And that's a pretty nice pattern. Hopefully this is successfully convinced you that Kubernetes doesn't have to be completely obtuse, doesn't have to be completely obfuscated. The real secret here is the Terraform provider, not just for DigitalOcean, but for Kubernetes as well. That is a very nice way to transparently manage and understand exactly what the desired state of your infrastructure is at any point in time. It's much better than Kubernetes YAMLs where you have no idea, am I applying this, am I unapplying this, what is the state of this when I said it was back there, but is it consistent? Who knows. And of course, as you saw here, you can also combine the Kubernetes resources with procedural bindings across a wide variety of other providers, including Helm, including DigitalOcean, including any other providers that you may have for whatever cloud platform you have. So given that and the ability to go in and do the kubectl commands once you export the kubeconfig as a way to sort of dynamically debug and verify as you're applying the resources one by one, this is a very nice way to help wrap your brain around what Kubernetes is, what it's doing, when things go wrong, what's going wrong, where it's going wrong, and then just learning the tricks like tracking log flows, etc., to figure out exactly what assumptions are breaking. And that will be it for this week. This was a little bit longer. Again, there's a lot of tech being combined here. We'll try and move a little bit away from the pure software engineering in the future, but I did want to make sure I re-recorded this one. So hopefully I'll see you next time, and hopefully this was somewhat useful to you. Take care. Have a great day.